Hello dear students, perplexed about addition reactions, how do they happen, what is the mechanism? Then this video and the next one in the series will help you to clear your doubts regarding addition reactions, how they take place and what is the mechanistic principles of that. In this video we shall be covering the basics, what are the various types of addition reactions and how to identify which one is which, and the mechanism of nucleophilic addition reactions. First of all, what are addition reactions? Simply a reaction in which pi bond changes to sigma bond. That means when a simple molecule is added across a double or a triple bond is what we call as an addition reaction. So if you notice, here's a pi bond. There are double bonds between the two carbon atoms. These pi bonds get converted into two single bonds, that is the sigma bonds. Depending upon what type of attacking reagent we have, we shall divide them into nucleophilic addition, free radical addition and electrophilic addition. If you are not very clear about the fundamentals of these three terms, I would request you to check out the other videos where we have dealt with them separately, and it will help you to clear your concept regarding the same. Nucleophilic addition reactions are very common in aldehydes and ketones, where addition takes place across the carbonyl group. C double bond O group is what we call as nucleophilic addition. Now, why are we calling them as nucleophilic addition? We will see a little later. Free radical reactions, free radical addition reactions, that means addition of a free radical, that means the initial attack takes place by a free radical. Here a very common example that we take is the addition of hydrogen bromide across an alkene in the presence of peroxide. Now this condition is very important, because if we don't have the peroxide, it no longer remains a free radical mechanism, it becomes an electrophilic one. Why and what are the differences between these two mechanisms we shall deal with in the next video. For the time being, what you need to understand is when it follows the free radical mechanism in the presence of a peroxide, our product follows the anti-Markovnikov addition, whereas when we do simple addition, our product follows the Markovnikov addition. Now again, so from one confusion we are leading you to another. No worries, we'll clear it now itself. Markovnikov. You have first of all an unsymmetrical alkene over here. CH3, CH, double bond CH2. Why are we calling it as unsymmetrical? If you notice, the two halves are not the same. That is why this is an unsymmetrical alkene. You are adding an unsymmetrical reagent. Unsymmetrical, you have H positive, Br negative. If I add only Br, that is bromine molecule, then it's a symmetrical agent. The two parts are equal. If you recall the line of symmetry that you do in mathematics. So here, this is unsymmetrical, this is unsymmetrical. When an unsymmetrical reagent is adding to an unsymmetrical alkene, the positive part of the adding reagent will go to the carbon containing more number of hydrogen atoms. This is what is called as Markovnikov rule. This is alternately stated as the negative part of the adding reagent goes to the carbon which is more substituted when an unsymmetrical reagent adds to an unsymmetrical alkene. More substituted. If you notice, this carbon has one hydrogen attached and one alkyl. So this is substituted. Whereas this doubly bonded carbon has got only two hydrogen atoms attached to it. So there is no substitution has happened. In other words, the hydrogen in the organic compound in the doubly bonded carbon has not been replaced by any other atom or group. So this is unsubstituted carbon, this is a substituted carbon, this is more substituted, this is less substituted. So the negative part of this will go to the carbon bearing lesser number of hydrogen, that is CH. Now please remember, CH3 doesn't come into the picture because CH3 is completely satisfied. It doesn't have a double bond, it doesn't have space for more. It can undergo substitution reaction, it can't undergo addition. Addition will only happen across the double bond. So positive part goes to the carbon bearing more number of hydrogen, or the negative part goes to the carbon bearing less number of hydrogen, or more technically stated, it is the negative part goes to the carbon which is more substituted. This is what is Markovnikov addition. That means addition according to Markovnikov rule, Russian scientist. Anti, this is against. According to Markovnikov rule, the hydrogen should go to this carbon and the bromine should go to the CH carbon. No, but it is not going to follow those rules. It breaks those rules in the presence of a peroxide. Why and how does this happen? We shall study in the mechanisms of both of these, which I shall be dealing with in a separate video parallelly. For the time being, we are concentrating on nucleophilic addition reaction. What is nucleophilic? That means addition, initial attack takes place by a nucleophile. Your first set of aldehydes and ketone properties reactions are all addition reactions. You have so many examples. Some I have listed over here. There may be reactions where addition takes place followed by elimination or hydration. Taking a very simple example over here, you have a ketone. You can also take an aldehyde. If I replace this R dash by H, then it becomes an aldehyde. So the ketone or the aldehyde undergoes nucleophilic addition of HCN in the presence of a base. How is the nucleophile generated? We see in the first step, in the presence of a base, HCN loses its proton from here, forms water and cyanide ion. The attack of nucleophile. This is a nucleus loving species, Cn negative. Carbonyl, oxygen is more electronegative. The double bond shifts towards carbon. Here Cn, because now this carbon becomes positively charged, oxygen becomes negatively charged. Cn shifts towards the carbon. If you notice over here, we are talking about mesomeric effect, wherein what is happening is, in the presence of this reagent, the electron pair of the pi bond is shifting towards one of the atoms. Gives us an intermediate. So Cn becomes attached to carbon because of the presence of the electrons on it, and we have O negative. Obviously, this type of a species cannot survive. It needs a proton in order to satisfy the electrons that it has. So here comes the water, and we have R dash COH, that is a cyanohydrin is our final product. Whereas an OH negative is released again at the end of the reaction. So here OH negative, which we were using initially, is regenerated as such without any effect on it. That is why this OH negative is what we call as a catalyst, a substance which helps to speed up a reaction but itself does not participate, is what we call as a catalyst. Participate in the sense that it will not be a part of the product. It is regenerated how it was added. There are many other examples of addition reaction, as I said earlier, like addition of sodium bisulfite. So we have H positive SO3 Na. Addition of Grignard's reagent C2H5 MgBr. Addition of hydrogen in the presence of platinum. Addition of alcohol in dry HCl. All these are examples of nucleophilic addition reactions. In your best interest, please first understand, practice writing them at least 3 times, and if the best is if you can teach it to any of your class buddy, any of your friends, or any of your parent who would be interested in listening to you, That will help you to clear a lot of doubts in your mind, and at the same time do good to the person whom you're going to teach. All the best.